I'm going to go through the independent practice for you guys. So the square root of 24, anytime we simplify a radical, we do so with a factor tree. So the square root of 24 will build our factor tree. We could start with anything you want to that multiplies to 24. I'll do 6 and 4. And 6 breaks down to 3 times 2. These are primes, so I'm going to circle them. 4 breaks down to 2 times 2. Those are primes, so I'm going to circle them. Now we're looking for pairs. The reason why we're looking for pairs is because if I have a pair of 2's, remember that all of this is under the square root. What's the square root of 2 times 2? Well, 2 times 2 is 4, and the square root of 4 is 2. So this stuff can come outside as a 2. Then I look to see what's left over. The 2 and the 3 were not in a pair. We multiply those leftovers and you put it inside. So the final answer is 2 radical 6. In number 2, we already know the square root of 16. The square root of 16 is 4. So I can just take that 4 out, and it would multiply by what's already outside. So it would be 3 times 4, which is 12. In number 3, it's radical 10 times radical 14. Well, the rule for multiplying radicals is the outside numbers could multiply to each other. In this case, the outside numbers are really 1 and 1. So that would be 1. And then the inside numbers multiply to each other. So 10 times 14 is 140. So if we have radical 140, I can start to break that down. If I want to simplify it, I'm going to use a factor tree. So the factor tree, you could go back to the 2 numbers we just had, which were 10 and 14. Or you can use 2 other numbers that multiply to 140. And 10 breaks down to 2 times 5. Those are prime. And 14 is 2 times 7. Those are prime. So again, I'm looking for pairs. I have a pair of 2's. The pairs go outside just as 1, 2, because remember, it's the square root of 2 times 2, which is 4. The square root of 4 is 2. And then the leftovers go inside, which was the 5 times 7, which is 35. 2 radical 35. Okay, and for the last one, same thing. Outside numbers multiply to outside numbers, so 3 times 4 is 12. Inside numbers multiply to inside numbers, 10 times 10 is 100. Well, square root of 100 is a perfect square, so I can square root that right away, and that's 10. So then I take the outside number 12, multiply by the 10 that we just got, and so that answer is 120. For the variables, it's really the same thing. Start with your 88. So we're going to make a factor tree for 88. I could do like 8 and 11. 11's prime. 8 is 4 times 2. 2 is prime. 4 is 2 times 2. These 2's are prime. We're looking for pairs. I have a pair of 2's that can come outside, and the leftovers stay inside. So 2 times 11 is 22. Now I have to deal with the variables. Remember, I'm going to ask myself, how many pairs do we have? Think like shoes, a pair of shoes. So if you have 3 things, like 3 shoes, how many pairs do you have? You have 1 pair. So that'd be 1m with an m left over. Another way to think about this is m cubed breaks down to m times m times m. There's my pair. That went outside. And then the extra, the leftover, went inside. Okay, so for p squared, I'll do that in a different color. P squared. How many pairs do we have? Just 1 pair. And there's no leftovers. So I can write that out as well. P times P, there was 1 pair that comes out, and there was no leftovers to go inside. Okay, I'll change the color again for the R's. How many pairs if there's 5? Well, there would be 2 pairs, so R squared, with 1 left over. Again, you could write it out. R times R times R times R times R. We have one pair, another pair, so these two come out, and then this one would go back inside the radical. So that's our final answer. 2mPr squared radical 22mr. Okay, next is rationalizing the denominator. When we rationalize the denominator, let me just rewrite this first. It's radical 45 over radical 10. Okay, rationalizing the denominator is when you can't have a radical in the bottom. That's a rule. You cannot have a radical in the bottom. So you multiply it times itself. Because the square root of 10 times 10 is radical 100. And the square root of 100 is 10. So the whole point, when you multiply a radical by itself, it just becomes that number with no radical anymore. So the square root of 2 times the square root of 2 is whole number 2. Okay, up top though, we multiply radical 45 times radical 10 and we get radical 450. But I need to simplify the radical. So step 1 is always to simplify the radical once we've rationalized. So the square root of 450, I'm going to break that down. Remember, I started with 45 and 10, so I can go back to that or two other numbers if I want to. So 45 is 9 and 5, and 9 is 3 and 3. So those are prime, and 10 is 5 times 2. Okay, I see two pairs, pair of 5s, pair of 3s. Those are going to come outside. So then I would have 15, and then my leftovers is the 2. So 15 radical 2 over 10. Okay, step 2 now is always to simplify the fraction. So don't look at the radical. The radical 2 is not included in this because radicals are only simplified with factor trees. So we're just going to look at the fraction part. The 15 over 10. We can divide both of those by 5. So divide by 5, I get 3. Divide by 5, I get 2, and put back that radical. So our final answer is D. In number 7, it has a radical in the bottom, but the difference between 6 and 7 is in number 7, it's a binomial. When this happens, you need a conjugate, which is the opposite operation of what's written in the denominator. So I'm going to multiply the top and bottom by the same thing. Let's deal with the top first. The top is distribution. Just remember that outside numbers multiply to outside numbers and inside numbers multiply to inside numbers. So 5 times 2 is 10. 5 times radical 6. Well, the 5 is outside and the radical 6 is inside, so they just combine together. Now on the bottom, it's always going to be the first in each group, like 2 times 2, which is 4, and the last in each group, radical 6 times radical 6. The minus in between, because it's really negative radical 6 times radical 6. Remember, when you multiply a radical by itself, it becomes that number with no radical. So let me see what we have at this point in time. We have 10 plus 5 radical 6 all over 4 minus 6 is negative 2. There's two things that we have to check. One thing is you have to see if you can simplify the radical. Well, radical 6 only breaks down to 3 times 2. There's no pairs, so that's already simplified. And then we have to simplify the fraction. When you simplify the fraction, you have to check all of these locations. So the coefficient of a radical plus the other numbers. There's nothing I can divide all of these by, and so therefore that was my final answer. 10 plus 5 radical 6 all over negative 2. Pause the video and try these on your own, and then I'm going to have the answers displayed here for you. Hit play when you're ready to see the answers. So here are the last 3 problems. Pause the video so you can have this screen here and you can check over your work.